In mechanics and physics questions, you will be asked to find usually three quantities. It's mass, the position, and the speed of an object in a certain situation. And the idea that you can use, the theorem that you can use in order to calculate these is based on the conservation of energy. And since the sorts of energy that we mainly deal with in mechanics and physics is potential and kinetic energy, we are going to be looking and be using at using conservation of mechanical energy. But what is mechanical energy? For a particular object, mechanical energy is basically the kinetic and potential energies of that object. And the total mechanical energy of an object is equal to the kinetic energy plus the potential energy relative to a position. And usually this is the ground. And we therefore generally come up with the idea that total mechanical energy is equal to kinetic plus potential energy, or TME is equal to KE plus PE. And it is important to know that for the law of conservation of mechanical energy, very much like the law of conservation of energy, if there are no forces, external forces acting on a system, the total mechanical energy will be conserved. And we can therefore derive very important formulas. Let's look at the total mechanical energy of the first diagram, the before diagram. It is equal to Ke, its kinetic energy, plus its GPE. We call it Ke1 plus GPE1. And afterwards, the total mechanical energy of the after situation would be TME2 plus Ke2 plus GPE2. And this is the same system, and I'm assuming that there are no external forces acting on the body except, well, the only force acting on the body is its weight. So this makes TME1 equal to TMA2. And if you equate that, you will get a very, very convenient and easy formula that you can use in almost any situation. That is KE1 plus GPE1 equals KE2 plus GPE2. Let's look at an example. If we were asked to find V when an object falls through a distance of 3 meters and with initial speed of 5 meters per second, we basically have to find V. Okay? So we look at KE1 plus GPE1 is equal to KE2 plus GPE2. Now, I know I have taught you that we can also use Suvat equations, but it is very important that we realize that later on there may be situations where, well, acceleration may not be constant. So this theorem is very, very important. So if you were to substitute the values in, you'd get 0.5 m multiplied by 5 meters per second is equal to mgh, which is 4 mass times g, is equal to half mv squared plus 1 mg. And you were to rearrange it, and you would get a speed of 9.8 meters per second. But what if there is a force acting on the system, an external force? And this force, when it moves through a distance, it is going to have negative work done on the system. So it's going to decrease the total mechanical energy, obviously. For example, air resistance. You're going to lose energy. You're going to lose energy that may have been converted into kinetic energy, right? So therefore, we come up with that when there is work done against the system, TME1 minus work done is equal to TME2, all right? And more specifically, it is the kinetic energy, initial kinetic energy at the initial gravitational potential energy minus the work done against the system. Work done against, remember, it's negative. If it's work done on the system, then it would be positive. But usually in life, this is so deep, but in life, we are going to deal with a negative work done. And that is equal to the after kinetic energy plus the after gravitational potential energy. Now let's look at the same situation but when there is a force. So find V when a constant air resistance force of 5 Newton meters acts on a system. And you equate that, you get KE1 plus GPE1 minus work done is equal to K2 plus GPE2. The equation we just learned before. Remember, this has to be work done against the system. You substitute the values in, and you therefore get a V value of 8.82 meters per second. And what do you know? This speed is less than the speed that we had calculated without the air resistance. So this idea proves to be very effective and very convenient. I very much encourage you to use this, as it will help you immensely.